Section 2.3, we're going to talk about function notation and making predictions. All right, so the other day we talked about functions. What was a function again? What made something a function? Each x value has exactly one y value. So to be a function, our rule was each x value has exactly one y value. That was our rule for being a function. And if we had a graph, we had a very, very easy way to tell if something was a function. How did we tell from a graph? We used something called the vertical line test. If we had a table, if our function was defined by a table, it was pretty easy to tell if it was a function or not. How did we do that? You just look at the x numbers, and if an x number repeats, it's not a function. The hardest one to tell was when we had an equation. When we had an equation, it was kind of difficult to tell if it was a function or not. Anybody remember how that worked? Bless you.
If the y has a null or an even exponent.
If the y, yeah, that's correct. If the y had an even exponent on it, then your equation is not a function. But if your y had an odd exponent on it, it was a function. All right, so here's a function. I'm just going to write one. Typically, when we've written functions so far, as an equation, I might write something like this. Y equals 3x squared minus 5x. So typically at this point, we've written functions as y equals. This is a special kind of function. This one is called quadratic. At this point, we've really only dealt with linear functions. Why is this one called quadratic? Anybody know? Because it has an x squared. That's right. And then what I might ask you to do with this sort of quadratic function is I might ask you to build a little table. So for example, I might ask you, plug in 0. What do you get when you plug in 0? 0. That was an easy one, wasn't it? I might ask you to plug in 2. What do you get when you plug in 2? 24. I think you missed a minus sign there. I think you would have 3 times 4 minus 10. I think you did a plus 10 there. So 3 times 4 is 12. 12 minus 10 is 2. All right. How about if I asked you to plug in negative 3? How much? Positive 13? No, I think it's bigger than that. Positive 27? No, I think it's bigger than that. All right, well, I'm just going to go ahead and do it. I'm going to take the 3, and then I'm going to plug in negative 3. And here's a suggestion that I have for you. This will help a lot, I think. Whenever you plug in a negative number, it's a very good idea to put it in parentheses. And that's going to help you a lot keep track of the order of operations. Minus 5 times negative 3. And here's why I think it's important to put this in parentheses, because I'll see students write this sometimes as opposed to the one with parentheses, and these two things are actually different. So if I put the negative 3 in parentheses and then I square it, what do I get? What's negative 3 times negative 3? 9. 9 times another 3 is 27, so that's 27. And then I have a minus and a minus, that's going to make a plus. Plus 15, that's 42. Like I was saying, very often I will see the students forget to write the parentheses. And what they'll do is they'll take this and they'll type it into your calculator. They'll type it into the calculator just like it looks, and the calculator will tell them the answer is negative 9. So they'll type in, just like it looks, negative 3 squared. And they'll say, my calculator says it's negative 9, but I know it should be positive 9. How come my calculator's wrong? The correct answer is, the calculator is never wrong. Never. I've never seen this calculator make a mistake. Who made a mistake? I did. According to the order of operations, what comes first, powers or minus signs? Powers. So what the calculator did, the calculator followed the order of operations. And what the calculator saw was, I have a square. So the first thing I do is I do the square. So the calculator did 3 squared. 3 squared is 9, and then it does the minus sign. The calculator did it correctly. So I think it's very useful if you just get in the habit of every time you plug in a negative number, put it in parentheses. And then you'll do that when you type it into your calculator, and when you type it into your calculator, you will then get the answer you need. Okay? So that's actually -9 there. Really helps if you put it in parentheses. All right, so nothing new so far. So here's the new thing. What we're going to do is we're going to use something known as function notation. So instead of writing the letter Y, I'm going to write this symbol. You love these, that's right. No? You disagree with me? All right, so we're going to write this as f parenthesis x equals 3x squared minus 5x. And this symbol confuses a lot of people. It shouldn't be confusing. All it means is this is our function name. Our function is called f. That's what that symbol means. And this parenthesis x is just very clearly saying x is the independent variable. That's all that parenthesis is saying. That parenthesis there is not a multiplication symbol, which is, I think, what confuses people. I kind of wish we would use a different kind of bracket there. But I think people see that parenthesis and they think multiplication. But it doesn't. All it means is our function, we're going to call our function f, and x is our independent variable. If x is our independent variable, then what's our dependent variable? F. F is our dependent variable. Those are the only 2 variables there. Okay? So if I have f of x equals 3x squared minus 5x, and I now write this symbol, f parenthesis 0, what does that symbol mean? I plug 0 in for the x value. All this symbol means is exactly what we did back up here in the table. Back up here in the table, I told you x was 0, you told me y was 0. This means exactly the same thing. All I'm doing right here is I'm telling you, use this function, use this rule, plug in the number 0. When you plug in the number 0, you get 0. What's f parenthesis -1? What does that symbol mean to do? It means wherever you see an x, don't write x anymore, write -1. So you're going to have 3 times, and again, I'm plugging in a negative number. Whenever you plug in a negative number, it's very useful if you put it in parentheses. It will help you get the right sign on your final answer. -5 times -1. How much is -1 squared? 1. What's 1 times 3? 3. And then I have minus times a minus. 2 minuses are going to give me a +5. 3 plus 5 is 8. Questions on that? All right, here's another function. Another function is g of x equals 3x plus 7. If I write that symbol, what are you going to tell me the answer is? 19. 12 plus 7, correct. So all this symbol means don't write x anymore, write 4. So that would be 12 plus 7, that's 19. What if I write this symbol? G at -5. You would tell me that is? Let's see. Yeah, I think -8's right. It would be 3 times -5 plus 7. That's -15 plus 7. That's -8. I agree. What if I gave you that symbol? G at dog. What does that mean? Nope. I don't write X. I write dog. That's all that symbol means. I don't know what 3 dog plus 7 means, but that's what the symbol would tell you to do. You don't write X anymore. You write dog. doesn't really make any sense, but that's what the symbol means to do. G at dog would be 3 dog plus 7. Whatever in the world that means, I don't know. What if I were to write this symbol? We won't be writing G of dog in this class ever again, I don't think. But this one we will write. What if I were to write something like G of A plus H? What does that mean to do? Plus 7. That's right. It means don't write the letter X anymore. Anywhere you see the letter X, don't write X, write A plus H. So we would have 3 A plus H plus 7. That's all that symbol would mean. Don't write X, write A plus H. And some people would say, well, can you simplify that? My answer is I don't care. If you want to, you could do that. And what's that called that I just did? How did I get rid of that 3? How did I take that 3 and get rid of those parentheses? That's called the distributive property. Do you have to do that? No, you don't. How about G at X minus 4? What would that symbol mean to do? Where X is, don't write X anymore, write X minus 4. That's all that symbol means to do. So we would write 3 times X minus 4 plus 7. And again, as far as I'm concerned, that's a perfectly correct answer. A lot of people don't like it left that way, so a lot of people will go ahead and simplify. That's fine. That's 3x minus 12 plus 7. So I guess we would write it as 3x minus 5. Again, I don't really care if you simplify it or not, but you can. On that. All right, another function. How about h of x is, oh, I don't know, somebody make up a nice linear function for me. Anybody got a nice linear function? Four x plus 2. That's a nice linear function. How do you know that's a linear function? Because that number is slope, and that number is y-intercept. This is in y. This is really just a fancy symbol for y. Y equals mx plus b. That's in y equals mx plus b form. So that has to be a line. All right, so same sort of thing. I'm going to ask a couple questions here. What's h at negative 3? And you would tell me? You would tell me negative 10, because it's 4 times negative 3 plus 2. That's negative 10. Now I'm going to ask you a new question, though. I haven't asked you this one yet. H of x equals negative 3. Those two symbols look very, very similar. The first one I wrote h parenthesis negative 3. This time I'm writing h of x equals negative 3. They look very, very similar, but they mean very different things. What does this new symbol here mean that I wrote? Now, it doesn't mean x equals negative 3. This symbol means x equals negative 3. This symbol means y equals negative 3, and you need to figure out x. I didn't tell you what x was this time. I just wrote it as x, didn't I? Okay, so here's the difference in these two problems. The first one, what I did, when I wrote h parenthesis negative 3, that means I was telling you the x value is negative 3. You need to figure out the y value. You told me the y value is negative 10. When I wrote this symbol, h of x equals negative 3, this means I did not give you the x number, because you still have the letter x there. Rather, I gave you the y number. So this symbol means I'm going to tell you y equals negative 3, and you need to figure out x. So how would you figure out x? That's correct. H of x, the formula for h of x is 4x plus 2. So instead of writing h of x, I write the symbol 4x plus 2 equals negative 3. And then I just need to go ahead and I need to solve that equation. And how would you solve that equation? 2 on both sides. 4x is negative 5. Divide by the 4. X is minus 5/4. Notice the big difference in those two symbols. where I place the number in the symbol makes a big difference on what you do. Where I place a number tells you if I'm giving you the x number or if I'm giving you the y number. All right, let's make up another linear function. How about f of x is, oh, we haven't used any fractions yet. We need some fractions. 2/3 x plus 4. We'll only do one fraction, I guess. We won't go too crazy. All right, so again, I'm going to give you two symbols that look very, very similar but mean very, very different things. So first I want to know f at -6, and then I want to know f at x equals -6. And I'm using the same number on purpose both times because I want you to really understand what the difference is. The first symbol I wrote means which letter is -6. This one means x is -6, where this one means y is -6. See the difference in those two? Where I place the -6 makes a big difference. All right, so I would have 2/3 times -6 plus 4. What's 2/3 times -6? -4, I think, because I think of 6 as being 6 over 1. 6 and 3 I can reduce. That's a 1 and that's a 2. So 2 times -2 is -4 plus 4 is 0. I didn't do this on purpose. Just a happy little accident here. I actually just found a very important point. If we were to graph this function, what did we just find? Close. Not the y-intercept. We found the x-intercept. How do you know it's the x-intercept? Because x was -6 and y happened to be 0. So we just happened to find the x-intercept. Didn't mean to. That was a happy accident, but I'm going to write that down. -6, comma 0. That's what we just found. We found the x-intercept. But we found it. All right, second symbol. F of x equals -6. This means to do what? Plug -6 in for y. So that means I have to solve 2/3 x plus 4 equals -6. Well, because if I take 2/3 and multiply by -6, 2/3 times -6 just happens to work out to be -4. And then -4 plus 4 happens to be 0. It was a fluke that it was 0. I didn't mean it to be. Just. Well, how do you multiply fractions? If I give you 2/3 and ask you to multiply by 6 over 1, there's two ways to multiply. Some people like to do this. Some people just like to multiply tops and multiply bottoms. So that would be -12 over 3. And then hopefully you would notice that -12 over 3 reduces. -12 over 3 reduces to be -4. That's one way to do it. The way I like to multiply fractions is this. I like to reduce at the beginning. Because if I reduce at the beginning, it keeps all my numbers smaller. And I'm better with smaller numbers. So what I notice is I have a 3 on bottom, and I have a 6 on top. 6 can be divided by 3. 6 divided by 3 is 2. So I cross that one out. That becomes a 1, and that one becomes a 2. And then 2 times -2 is -4. So I've got -4 on top and 1 on bottom. Well, I don't really need to write the 1 on bottom. So either way is correct. I prefer the second way. I prefer to reduce at the beginning and keep all my numbers as small as possible. Many people disagree with me. Many people like to just say, I'm always going to multiply tops, always going to multiply bottoms, and then reduce later. Whichever way you like better is good with me. I don't care. All right, back up to this one here. F of x equals -6. That means we plug in 2/3 x plus 4, and we set it equal to -6. How are you going to solve that equation? Subtract 4 on both sides. So I get 2/3 x equals -10. And then you said divide by 2/3, which is correct, but I don't like dividing by fractions. A better idea, I think, is to multiply by the reciprocal. And reciprocal is a fancy word for flip it over. That's correct. So what I would prefer to do, instead of dividing by 2/3, I prefer to multiply by the reciprocal. Again, either way works. If you divide by 2/3, in order to divide fractions on the right-hand side, you're going to have to flip and multiply anyway. So this is my preferred way. I can reduce, the 2's reduce, the 3's reduce. On the left-hand side, I have x equals, and then what do I have on the right-hand side? What's negative 10 times 3 halves? Negative 15? X would be negative 15. Questions on that? All right, one more little problem here, and then we'll do one out of the book. Oh, let's see, how about f of x equals 3/5 x minus 6. I'm going to ask you to find 4 things. I want you to find f at, I don't know, give me a number.
-3.
How much?
-3.
F at -3. That's one thing I want you to find. And then I want you to find f of x equals, I don't know, give me some other number. 7. And then I want you to find the x-intercept. And then finally, I want you to find the y-intercept. All right, so you work on those 4 things for a minute. All right, the first one, f at -3. What does that symbol mean to do? Plug that in for x. So you're going to have 3/5 times -3 minus 6. And then what do you do? What's that? Yeah, just simplify. And what I would do for this problem probably is I would probably just grab my calculator. Because I see I'm going to have fractions. So I'm going to take 3/5. I'm going to multiply by -3. Then I'm going to subtract 6. That's an okay answer, but I would really prefer a fraction. How come I would really prefer a fraction? Very good. This is kind of the standard rule of thumb. If the problem starts with fractions, the problem should end with fractions. If the problem starts with decimals, then the problem can end with decimals. So in this case, since the problem started with fractions, I should really give my answer as a fraction. How do I tell my calculator, give me that answer as a fraction? Math, enter, enter. So remember, once again, you never ever in your life have to add, subtract, multiply, and divide fractions. You may use your calculator. So our answer there would be -39/5. F of x equals 7. What does that mean to do? Plug 7 in for y. So we're going to have 3/5 x minus 6 equals 7. Oops, equals 7. Oh, what I'm writing there. How do you solve for x? Add 6 over. So 3/5 x is 13. And then multiply by the reciprocal. So multiply by 5/3. Think of 13 as being 13 over 1. X equals, this time I don't think I can reduce because I have a 13 there and a 3 there, nothing reduces. So 65 over 3. 13 times 5 is 65 over 3, I think is the best I can do there. Let's go to the next one. This one, I'm going to go to y-intercept because y-intercept is the easy one. What's the y-intercept? Again, I would prefer 0, -6, but I would accept just -6. And how do you know the y-intercept is -6? This is in y equals mx plus b form. That right there is your y-intercept. That one was easy. You don't really need to do any work for that one. And finally, how about the x-intercept? That would be the same as asking this question. I could also write it this way. That would mean exactly the same thing. That symbol would mean find the x-intercept, because I'm telling you x is not 0. I'm telling you y is 0. All right, so we have 3/5 x minus 6 equals 0. Add the 6. 3/5 x is 6. And then again, to get the x all by itself, we multiply by the reciprocal. We multiply by 5/3. And again, I can think of 6 as being 6 over 1. And again, I see I can reduce. I have a 6 on top and a 3 on bottom, so that's going to reduce to be a 2 over 1. Go ahead. That's what the x-intercept always is. The x-intercept always means y is 0. So I'm just telling you that instead of saying find the x-intercept, I could have written that symbol. And that symbol would have meant exactly the same thing. That symbol means y is 0, which means I'm asking you find the x-intercept. So that's just two different ways I could write the exact same question. I could say in words find the x-intercept. I could write in symbols f of x equals 0. What's the symbol I would write if I wanted you to find the y-intercept? What would the symbol for that look like? F at 0. That would be the symbol for find the y-intercept, because now I'm telling you x is the number 0. When I tell you x is the number 0, that's always the y-intercept. Now the big question, why do we use this symbol? Why not just use the letter y? I like y a lot. Why are we doing this? Any ideas? All right. We're taking a business class now. Pretend. In business, very often you talk about supply and demand. In economics anyway, you talk about supply and demand. One of these equations is the supply function. One of them is the demand function. Which is which? What's that? You can't tell. All right. I see, even I did it backward. If I were to write them that way, which one's the supply function, which one's the demand function? Supply is the one I called S, and demand is the one I called D. This happens in a lot of situations, not only in math classes, but in a lot of other areas. Quite often you have more than one equation that you're dealing with at the same time. It's just very convenient to give them different symbols. Okay? So that's one reason we do this notation. It's not the only reason. The other reasons why we do this symbol, this notation, turns out to be much, much better for doing things that involve calculus. And that's really, I think, what originally generated this kind of notation. Of course, we don't have to worry about that today, but I think that's why we teach it now. This is part of the goal of this course, is to get you ready to take other math classes. This symbol is very, very common in pre-calculus and calculus. So that's another reason why we use it. For now, why do we use it? For now, we use it because in the very near future, we're going to have situations where we're going to have more than one equation at a time, and it's very helpful to be able to label them that way and tell them apart. Okay? Questions on that?
The one that the x-intercept, why does the 6 become a positive?
Because it's a negative here. To get it to the other side, you have to do a plus 6 on both sides. To move the 6 to the other side of the equal sign, you have to change the sign.
Okay.
Other questions?